So what happened in 1965, and why did the Russians fail to capitalize on their commanding lead in the space race? So during this talk, I'm going to talk about 5 very important Russians that were absolutely critical to their rocket program. The first one is Sergei Korolev. Korolev was the chief designer, and he was so important to the Soviet space program that no one ever mentioned his name, because they were concerned that if his name leaked out, that he'd become a target for assassination. And he was the one that led the Soviet Union in developing Sputnik, sending the dog into space, the first man in space, first woman in space, and spacewalks. But in the background were men like Valentin Glushko, who was a chief designer for the Soviet engines, the rocket engines. Vasily Mishin, who was second in command to Korolev in the Soviet space program. And 2 of Korolev's competitors, Mikhail Yangel and Vladimir Chelomey. And we're going to talk about the role that each one of these men played in the history of the Soviet space program and the competition between these men that led to some missteps in the Soviet program. So let's talk about Korolev. He was born in January of 1909 in Ukraine. His father was a teacher of Russian literature. And his parents had a very rocky marriage. And when he was 9, his mother divorced her first husband and married Grigory Balinin. Now, Grigory was trained as an electrical engineer, and he actually came to the UK and trained in the UK as an electrical engineer. And he really served as the mentor and coach for Korolev to enter a technical field as he was growing up. In 1923, he took his first flight as a passenger in a plywood biplane called the Grigorovich M9. Now, Korolev's family lived near a military base. And just about every day, Sergei would go to the fence of the military base and watch the officers tend to their aircraft, either repairing their aircraft or getting ready for flight. And one day, one of the officers who'd seen him there just about every day came over and said, "Hey, would you like to take a flight?" And of course, he was terribly excited to do that. And that's what really sparked his interest in aviation. So he really started in his training in aviation. The next year, he enters the Kiev Polytechnic Institute to study aviation. And this is the same institute where another famous Russian, Igor Sikorsky, lectured. Sikorsky left the Soviet Union after the Russian Revolution, came to the West, designed airplanes, and eventually formed a company that developed helicopters. And that company is still here with us today, Sikorsky Helicopter Company. In 1926, Korolev enters Moscow Higher Technical School to study aeronautics. And one of the very important lecturers there was a man named Andrei Tupolev. And Tupolev is a very famous designer of aircraft for the Soviet Union. And it turns out that Korolev's relationship to Tupolev becomes very, very important later in life. 1926 was also a very important year in rocketry, because that was the year that Robert Goddard, here in the United States, demonstrated the first liquid-fueled rocket. Now, Korolev, Glushko, Mishin, Yangel, and Chelomey all had passion around spaceflight. And all of them actually read Jules Verne and read the work of a little-known Russian school teacher who turned out to be very prescient in the concepts of space travel. His name was Konstantin Tsiolkovsky. And Tsiolkovsky developed many of the theories on how to launch rockets into space in the early 1900s, way before Goddard did. And Goddard was an experimentalist, Tsiolkovsky was just a theoretician. And he wrote a lot of science fiction. So all these Russian scientists were reading Tsiolkovsky and Jules Verne, becoming passionate about flight, but it was Robert Goddard who was the first person to actually demonstrate a liquid-fueled rocket. In 1929, Korolev needs to submit his senior project, and he works with Andrei Tupolev to design a light aircraft. And that same year, he joins a group of amateur rocketeers. Okay, these are rocket enthusiasts. It's called the Group for Studying Rocket Propulsion, and the acronym in Russian is GIRD, G-I-R-D. And GIRD built and designed and tested small rockets with the goal of using them for space exploration. So they were doing some of the initial work in the Soviet Union that Robert Goddard had done here in the United States. And in 1933, GIRD launched its first liquid-fueled rocket, called the GIRD-9, and the arrow points to Korolev standing next to the GIRD-9. Well, GIRD was so successful that the military said, you know what, you guys are doing some interesting things. We want you to become part of a research institute. So it was merged with the laboratory that had already existed called the Gas Dynamics Laboratory and became the Reactive Scientific Research Institute and was funded by the Soviet military with the purpose of developing rockets and missiles for the Soviet Union. And that's where Korolev met Valentin Glushko. Now, Glushko was also born in Ukraine. As a teacher, he read Jules Verne. As a teenager, he read Jules Verne and Konstantin Tsiolkovsky and his novels on space travel. He studied physics and mathematics, but never finished his degree. He got a job at the Gas Dynamics Laboratory and decided that this is what he wanted to do, so he continued doing work there. And it was there that Korolev and Glushko first met. Glushko and Korolev collaborated on a rocket-powered glider. Glushko designed the engine, and Korolev and his team designed the glider. And they worked pretty well together early on, and developed the technology for a rocket-powered system. But then the Soviet Union walked into a very dark period in its history between 1936 and 1938. Joseph Stalin decided that he needed to purge any dissenters of his regime, and so he captured and collected dissident members of the Communist Party, as well as scientists and engineers, and put them on trial. And one of the people that they captured was Valentin Glushko. And so he was arrested in 1938, and he was tortured, and he was forced to give up names, and he gave up the name of Sergei Korolev. And he said, Korolev is a conspirator against the Communist Party. And in exchange, he was given an 8-year prison sentence for his information. Well, they showed up at Korolev's apartment, they arrested him at 4 o'clock in the morning, and they accused him of being a member of an anti-Soviet counter-revolutionary organization. He vehemently denied it. He wrote letters to Stalin just about every month to profess his innocence. But on the testimony of Glushko, Korolev was sentenced to 10 years hard labor in a Siberian gold mine in Kolyma. And Kolyma, the Kolyma Gulag is near the Arctic Circle. It's about 280 miles south of the Arctic Circle. The average winter temperature was 36 degrees below zero. That's the average. So you know that there were some very cold days. And it was very, very tough labor. These are some photographs from Kolyma. This is not in the winter, this is in the springtime. But these prisoners were forced to dig trenches, to go into the mines, to recover the gold. Korolev had a very tough life when he was in the Gulag. He suffered from scurvy, he lost his teeth, he had a heart attack, and his jaw was broken by a beating from the prison guards. But all this time he was professing his innocence and writing to Stalin or writing to anybody who might be able to get him out. Well, in 1939, Stalin sees the writing on the wall and he realizes that there's probably going to be a war with Germany. And so he has a change in thinking. He says, look, all these scientists and engineers, we're going to need them to help us build our military. So they're going to remain in prison, but we're going to call it a pseudo-prison. They're not going to have their freedom, but they're going to be they're going to be told to work on military projects. And so all the scientists and engineers that were in prison were brought to these special centers called Sharaska. One of them was Andrei Tupolev, and Tupolev lobbied for Korolev's release. So a year and a half after Korolev was put in the Gulag, he's released. He's released. and he shows up and works in Tupolev's group on airplane design. And in 1944, he moves, because of his experience with rockets, he moves to another institute that was studying solid rocket propellants. And who was he going to work for? But Valentin Glushko, the guy who named him and the guy who eventually led to his imprisonment in the Soviet Gulag. You can imagine that that was not a very comfortable relationship. But they did work together. But then, through the war, the war ends. The United States sends a group of Army officers to Germany in a program called Operation Paperclip. And the purpose of Operation Paperclip was to hoover up all the German technology and bring it back to the United States. And they entered the camps where they went to Peenemünde. They went to the camps where the V2 rocket was being manufactured. They captured the technology, they captured the scientists, including Werner von Braun, and about 150 of the people that worked with him. And the Soviets were left just with the scraps. They captured the remaining scientists and engineers. They captured pieces of German missiles, brought them back to the Soviet Union. And because of his experience in rocketry, Korolev was sent to Germany to assess the state of the German rocket program. And so he becomes kind of an authority on the German rocket program. And he's put in charge of a missile program with Vasily Mishin, one of the other people that I mentioned, who was his second in command. And he's basically told to replicate the German V2 rocket. And Glushko is going to work with you and develop the rocket engines. So they're together again. And the result was the Soviet R-1 missile, which is essentially the Soviet version of the V2 rocket from Germany. So then Stalin dies in 1953, and Nikita Khrushchev becomes party leader. Now Khrushchev is a party man. He's not party like let's have drinks together, communist party. But he's not a technologist, so he's relying heavily on the scientists and engineers. Okay, and he gets information that the United States is building an intercontinental ballistic missile, which we know today is the Atlas missile, at a program in San Diego at a company called Convair. And he's getting very nervous. In 1953, the Russians exploded the first hydrogen bomb. It was only 9 years after the US explosion of the hydrogen bomb, and they needed a missile to deliver it. And so they go to Korolev and they say, we need you to build us a rocket that can deliver the hydrogen bomb. So he's directed to focus on ICBM development. Now, up to this point, he was doing rocketry, but for military applications that were land-based, not intercontinental. And so his work is transferred to this man, Mikhail Yengel, who I mentioned earlier. And Yengel is tasked with developing long-range rockets for ground-to-ground combat. And so Korolev starts working on this rocket called the R-7. Now, one of the requirements of the R-7 was it had to carry a very large payload. The Soviet hydrogen bomb was about 5.5 tons, 40% heavier than the US hydrogen bomb, which means that they needed a much larger rocket to deliver it to its target. And so he designs the R-7, and it was successfully flown in August of 1957. Now, he's doing this under the auspices of the military, but his real passion is to use it for space exploration. And just as a comparison, here's the size of the R-7 relative to the US rockets at the time. The Atlas is the one in the middle. You can see it's substantially smaller than the R-7. It didn't need to be as big because it wasn't carrying such a high payload. And the engines on the R-7 were again designed by Valentin Glushko. And they were using kerosene and liquid oxygen as the fuel sources. And for space exploration, this is fine, because you've got plenty of time on the launch pad to load the rocket with liquid oxygen, but it's not that great if you're using it as a deterrent. The R-7 was used to launch Sputnik, and it was actually used as part of the Vostok program, the Vakshot program, It's probably one of the most used rocket designs in the history of rocketry. It's still, versions of it are still used today by the Soviet Union. Well, Sputnik goes up, and Khrushchev didn't really care much about putting a satellite into space. He kind of humored Korolev, and then the world went, excuse the term, ballistic in its enthusiasm about the accomplishment of putting a satellite into space. Khrushchev never anticipated this type of press, and he said, "This is fantastic, right? We need to now continue our space program because we have demonstrated our technical and engineering capabilities that are superior to the West, and that's what's going to move the communist cause forward." So he decided he's going to continue to fund the space exploration program. But the Soviets had a dilemma. The way the Soviets funded their program, it was all through the military. So the Central Committee determined which programs would be worked on, and they would direct the military to support those programs. The problem is the military had no interest in space exploration. The military was only interested in space in as far as it could further their military objectives. And so trying to convince the military to fund it at a sufficient level became a challenge. The next problem that they had, as I mentioned, was that the R-7 rocket used kerosene and liquid oxygen. Well, if you're using kerosene and liquid oxygen on a missile that's going to be a deterrent, that's a problem, because it takes time to load liquid oxygen onto the rocket itself. So in fact, it could take several hours to get the rocket ready to fire, and so it's not going to be a piece of weaponry that will quickly respond to a threat. And that was a question of conflict within the Soviet military. Now, Glushko and Yankel, who I mentioned before, advocated using a non-cryogenic propellant system. So this is an organic compound and a highly oxidative material that when you put them together, they automatically ignite and the rocket goes up. And this is what we use when we make maneuvers in space today. These are called hypergolic fuels. You just mix the two together and they ignite. You don't need an ignition source. The advantage is you can put them in separate tanks, you can store them, and so if there is a strike, the missile is ready to go. You don't need to wait to fuel the tank with oxygen. The problem is, these are very corrosive and very toxic compounds. And so this led to a battle between Korolev and Glushko, because Korolev wanted to use these missiles for space exploration and put men on them. And he said, "I'm not going to put men on a machine that's filled with such toxic and corrosive material." So in 1960, Korolev proposes a grand lunar program, okay, for space exploration. So this is even before Yuri Gagarin goes up. Okay? He's already thinking about what we can do, what the Soviet Union can do to reach out in space beyond the moon, in fact. He's talking about having a piloted satellite for reconnaissance and anti-satellite warfare as early as 1963. He's proposing a crewed circumlunar mission by 1964, and a crewed circumlunar mission to Venus and Mars by 1967. So he was really out there in terms of very, very ambitious for the Soviet program. To do that, you need a very big rocket. And so he proposes the development of what he's calling the super heavy rocket, the N1. And this is the rocket that would be big enough to carry the men and the payload required to do these circumlunar, circumvenus, and circummars missions. The plan is approved by the Central Committee, and the funds are approved to do the design. So the way the Soviet funding happened, you would get first a preliminary chunk of money to do a design. The design would be reviewed, and then after review, you'd get another chunk of money to actually begin the construction. So Korolev gets money to start doing the design. Now he is the director, he's called the chief designer, and he now is using that money to fund various aspects of the development of the N1 rocket and the other elements of the space program that he has proposed. But he's got competition. And the two people that are competing with him are Vladimir Chalamet and Mikhail Yankel. Now, Chalamet was a very, very talented engineer, very close to the Communist Party, as was Yangel. Chalamet was working on developing anti-ship missiles, so for the Soviet Navy, and he developed the cruise missile technology that the Soviet Navy had developed for anti-ship engagements. And as I mentioned before, Yangel was involved with developing long-range missiles for the Soviet Union. They saw that funding that they were hoping to get was now going to Korolev for his space exploration, and they said, we want in on this. So Chalamet put together a proposal that countered Korolev's proposal, and Yangel also put in a proposal. The problem was Khrushchev was not a technical person, and so he tried to cover his bases by funding all three. And as I said, Chalamet was very political. He hires Khrushchev's son Sergei to work in his group. And so he had a little bit of an in with Khrushchev, and was able to feed some of his ideas to him so that he might get funding. While that's going on, Glushko and Korolev were still arguing about the propellants to use in these rockets. And eventually this erupts, and they refuse to work together. And so Khrushchev now had to deal with these two guys that were fighting. He needed both of them to get what he wanted, which is more prestige for the Soviet Union. That was just not going to happen with these two. So Korolev, in his frustration, says, you know what, Glushko? I don't need you. I'm going to use this guy, Mikhail Kuznetsov. Now, Kuznetsov is a very talented engineer, but he was an engineer designing jet engines, not rocket engines. But Korolev turned to him to say, look, I need you to help develop rocket engines for the N-1 rocket, which he did successfully do, by the way. And Khrushchev becomes so frustrated with this fight between he and Glushko that he takes some funds away from Korolev and gives it to Chalamet and say, you work on it too, right? So now he's spreading the funding very thinly among the various groups within the Soviet Union. In 1961, John Kennedy sets the goal of sending a man to the moon and returning him safely back to Earth. At this point, the United States had just done a 11-minute manned mission suborbital with Alan Shepard. So we didn't know anything about how we're going to get to the moon, what we're going to need to get to the moon. I mean, people had talked about it, but the idea of going to the moon by the end of the decade was never anybody's plan. Now we had to accelerate our focus on it. The first thing you need to determine is how you're going to get there, which we call the mission profile. And there's actually 3 mission profiles that are possible. The first is called direct ascent. Direct ascent is pretty simple. You have one very big rocket. That's the only rocket you need. You take that rocket, you go up into Earth orbit, you use the same rocket to go to the moon, you use the same rocket to land on the moon, you use the same rocket to get off the moon, back to Earth, and then land back on Earth. You just need one piece of equipment. The problem with direct ascent is you need an enormous rocket, because if you're just using one rocket, you're carrying a lot of dead weight with you when you expend the fuel. So that's a big technical problem, getting a rocket big enough to be able to do that. The next is called Earth orbit rendezvous. In Earth orbit rendezvous, you use smaller rockets to get stuff up into Earth orbit. And then you build a rocket in Earth orbit to take you to the moon, land on the moon, and come back from the moon. It's a little bit more complicated in terms of the process steps to get to the moon and back, but it's more tangible because the rocket doesn't have to be as big. In the United States, we chose lunar orbit rendezvous. This requires the smallest rocket, but it's the most complicated mission profile because you have to do rendezvous and docking, not in Earth orbit, but in lunar orbit. And in 1961, we didn't know how to do rendezvous, and we didn't know how to do docking. And it took a lot of courage to say, it's okay, we can do it while we're orbiting the moon. If either of those two fails, you're stranding your astronauts in lunar orbit. But the United States decided to do lunar orbit rendezvous. So in 1962, NASA approves the development and the construction of the Saturn V rocket and the 5 engines that are used in its first stage. These are called the F1, Rocketdyne F1 engines. It approves, in July of the same year, the Lunar Orbit Rendezvous mission profile. Is it done? the Soviet Central Committee approves the design work to commence on the N-1 rocket. Now, Kuznetsov was a very good engineer. He made a very competent design for a rocket engine. The problem was he could not scale it up to large scale. So in order to be able to lift the N-1 rocket off the platform, off the launch pad, you need 28 engines. That's a lot of engines. But it's doable. And the Central Committee approves Korolev's design to do Earth orbit rendezvous. And the idea was to use the N-1 rocket to get stuff into Earth orbit, build the machine up there, and head to the moon. But the military wants to support Chalamet and Yangel because the projects that they have proposed have clear military applications. Both of them can be used in launching satellites, in developing space weaponry, whereas Korolev was very focused on space exploration. In 1963, NASA signs a contract with North American Aviation and Grumman Corporation to design and build the command module, the service module, and the lunar module. And Mikhail Yangel proposes another rocket to get to the moon. So even in 1963, the Soviets had not completely finalized on what type of rocket they were going to use to get to the moon. And the Soviet Research Council recommends that they accelerate their efforts to get to the moon because they see that the United States is starting to make progress. And so they approve a 5-year space plan, which includes both Chalamet's parts of Chalamet's program and Korolev's program. Okay? And the target is to complete all this work by the 50th anniversary of the Russian Revolution, which is going to be in 1968. In 1964, it becomes evident that the 28 engine N-1 rocket is not going to do the job. And so Korolev changes the mission plan from Earth orbit rendezvous to lunar orbit rendezvous. Now, that means all the work that they did to design the pieces of equipment used for Earth orbit rendezvous is no longer applicable. They have to start from scratch and do lunar orbit rendezvous. This is in 1964, with the target of getting into the moon in 68. In order to accommodate the lunar orbit rendezvous, they had to add 2 more rocket engines. So now they've got a 30-engine machine. This is the design of the rocket engines for the N-1. And this is really, really tough because these engines are not what we call gimbalable. The 4 of the 5 engines on the Saturn V are on gimbals, which means they can be directed in 2 dimensions to basically turn the rocket. Well, these rockets are not on gimbals, they are fixed, which means the only way to turn the rocket is to reduce the power on one side and increase the power on the other side, which means that the control system required to manage these engines is really, really complicated. And in 1965, the Soviet military approves the building of the Soyuz spacecraft for the lunar missions. And finally, they come to their senses. They cancel Chalamet's program and focus all the funding on Korolev's program. So let's take a look. At the end of 1965, both countries had decided on lunar orbit rendezvous, but the United States had a 2-year head start. Both countries had developed heavy lift rockets, but the United States had a 3-year head start. Both countries had decided what they were going to use for crew capsules, but the United States had a 2-year head start. And both countries had designed a lunar lander, but the United States had a 2-year head start. So even though the Soviets had a lead at the beginning in some of the early milestones in the Soviet space program, the United States had taken the lead because they had made early decisions on how they're going to get to the moon. And in 1966 was a very fateful year for the Soviet program because Korolev was hospitalized with an intestinal polyp and he undergoes surgery. And unfortunately, the doctors discover a massive tumor and Korolev dies 9 days later, which means he was the lead for the entire space program from the 1950s all the way to 1966, responsible for all major milestones of the Soviet program, was leading the lunar program for the Soviet Union, and he dies. Well, his second in command is Vasily Mishin. He takes over, and here's Vasily. Vasily is a different kind of man. Korolev is a very hard-driving, no-nonsense kind of director. mission is not, he's technically very sharp, but he doesn't have the drive or the political gravitas that Korolev had. And he inherits the Soviet Soyuz program and completing the N-1 rocket. And in March of 1966, the United States does the first docking of two ships in Earth orbit in Gemini 8. The Soviets are trying to catch up. They want to demonstrate rendezvous of two spaceships. They have not done this yet. And so they sent up Vladimir Komarov in Soyuz 1. And the objective was to send Soyuz 1 up. The next day they'd send up a second Soyuz spacecraft. They would rendezvous in space. They would demonstrate rendezvous and then come back to Earth. Well, there was trouble from the start. The left side solar panel on the Soyuz spacecraft did not deploy. And that was the one that was powering all the sensors that would orient the ship in space. It was running on batteries, and the batteries were rapidly depleting, and so he was told to come back to Earth. Because he did not have the sensors to orient the craft in space, he had to do manual orientation, and to his credit, he brought the spaceship in within the angular window to actually re-enter the Earth. But unfortunately, the parachutes didn't open. So the main parachute got tangled, the main parachute didn't open, the backups got tangled up, and so he landed back on Earth at greater than 120 miles an hour, and he obviously perished, and that really set the Soviet program back quite substantially. In 1968, the CIA reported that the Soviet Union was going to attempt a circumlunar mission in late 1968 or early 1969. Now, at this point, the United States had not left Earth orbit, and the lunar module was going to be tested on Apollo 8 within Earth orbit. Well, the lunar module was not ready, and so NASA made the bold decision to send Apollo 8 to the moon on a circumlunar flight to beat the Soviet Union, and they were successful. And the lunar module was tested on Apollo 9. And so, as I said, it was reassigned in December of 1968. That was the picture that Joe put up. The first picture of Earthrise was taken by Bill Enders on Apollo 8. All right, so now, I mentioned that the N-1 required a very complex control system to independently control the thrust on the 30 engines. Because time was getting short, and because of the difficulty of testing 30 engines on the ground, the Soviets decided that they were going to skip the ground tests. And they were going to just run the rocket and test it in flight. And in February 21st of 1969, they made the first flight of the N-1 rocket. The engine shut down after 69 seconds. It was 8.7 miles downstream, falls back to Earth. They realized, or they discovered that there was a fuel rupture in one of the lines, and so they lost the first N-1 flight. They knew that the Americans were going to launch Apollo 11 in July of 1969. So they decided to try to beat that date on July 3rd. They made the second flight of the N-1 rocket, and after 10.5 seconds, the rocket exploded on the launch pad. It shattered windows for 25 miles, and they found pieces of the rocket 6 miles away. It's the largest explosion, unintended explosion on Earth at the time. And in just less than 2 weeks after that, Apollo 11 went up with Neil Armstrong, Buzz Aldrin, and Michael Collins. We made the landing on July 20th, and on July 24th, returned all three men back to Earth, essentially ending the moon race in favor of the United States. But the Soviets were not deterred. They wanted to continue, so they made a third launch. There was another control malfunction, and the rocket disintegrated in 48 seconds after launch. And they did one other test in 1972, and it also failed. So they never got the N-1 rocket to work properly, even though it was quite an advanced piece of machinery. They could never get it to work. And so the Soviet program was canceled in 1974. Valentin Glushko, the guy that had all the problems with Korolev, was put in charge of the program. The mission was kicked out, and Glushko canceled the N-1 rocket program, and that basically ended any aspirations the Soviet Union had about going to the moon. So why did the Soviets fail? First of all, their funding came from the military. The military is only interested in one thing, and that is how they can use space for defensive or offensive purposes. For the Soviet Union, they had very little interest in doing any type of space exploration. There was an intense rivalry and competition among the various technologists: Korolev, Glushko, Chalmers, Mission, and Yangel. The N-1 design was too complex for its time, but it was not too complex forever. Because if you compare the 30 rocket N-1, shown on the left, to the 33 rocket SpaceX Super Heavy, there's a lot of similarity. And the SpaceX Super Heavy does not use gimbaled rocket engines. It uses a control system that is based on digital technology that's able to control the power of each rocket and has successfully flown many times. So even though the design of the N-1 was quite feasible, the control system was just not capable of managing that many engines. There were a lot of delayed decisions and parallel programs, diluting funding and not making the critical decisions that were required, and they had very ambitious and, I would say, unrealistic timelines, driven mostly by political motives and political infighting. And with that, I will stop and answer any questions you have. Thank you very much. Do you want to pass the mic around?
Yeah, I have a second mic.
You have a second mic. Okay, well, Joe was going to pass out the mic.
And I didn't see Val out back. Richard, you want to start us off?
Well, you mentioned that the Russian nuclear bomb is significantly heavier
Yes.
than the American. What was the reason for that?
Well, it was basically, they had one of the issues is how do you concentrate the explosives to implode the nuclear material, right? And the technology that the Soviets had was a little bit inferior, which required them to use more complicated design, and so it made the whole thing quite heavy.
Did the Soviets have any more accidents with their cosmonauts?
They did. They had quite a few. The first real tragedy that the United States had was Apollo 1, right? The 3 Apollo astronauts died because of oxygen in the capsule that was fuel for a spark. Actually, a couple of years prior to that, the Soviet Union also had something very similar. They didn't talk about it. The astronaut's name, I think, was Bodorenko, if I remember right. But they've had several other losses of life. Komarov was the first one in space.
Any other questions? Here we go.
The first one in space was Gagarin.
That's right. It was only 65 years ago, 3 days back, that he went up.
The Apollo program computer technology, looking back on it, quite limited.
Yeah.
We often hear the story that our cell phones had more computing power than they did.
Yeah, it's
How
true.
did the Soviet computer technology at the time compare to Apollo program?
Yeah, I think it was not as advanced as the Apollo program. And the other real challenge is, these events, these excursions that happen on rockets, they happen very, very fast. And you have to have sensors that can sense it adequately, and software that can react to that information quickly enough to be able to make a correction. And the design of the software is also, it's in its early stages, right? Software development in the 1960s in the early stages is not something that we've gotten much better at designing software that can more rapidly respond. And the sensor technologies improved significantly today as opposed to what was there. So conceptually, the N1 rocket makes sense. I mean, it works technically. The challenge is the engineering challenge of getting everything perfectly right to be able to make it work properly.
And I'll come to you next, and then you, and I'll toss out to current day, we're in a bit of another race to the moon.
Yep.
We're making good progress. Do you have any assessment between China and Russia and their capabilities, how you think this might play out?
Yeah, I think China is the country to watch for, because I think Russia's got its hands full right now with everything that's going on in the Ukraine. But I think China is really going to be an important adversary in getting back to them.
They move fast.
They do.
We talk a lot.
Okay, this is kind of similar. How would you characterize the current Russian space program?
So after all these things, the Russians decided that they were going to focus space on military applications and Earth orbit applications. They do a lot of probes, so unmanned. They still do unmanned space exploration, but they don't have a manned space program that's out of Earth orbit.
The testing of the N1, what was the problem with that? Is it just they didn't give it enough time? I know we do a fantastic amount of testing of our engines and stuff
Yeah.
like that.
So I think it was a couple of things. I think the capability that the Soviets had at the time to test 30 rocket engines. I mean, okay, so what did we do? We were testing every single F1 engine before it went on the rocket. The Soviets didn't have the infrastructure to be able to do that effectively. And they didn't have the time. I mean, they could have gotten the infrastructure if they had the time to do it, right? They were late on a lot of decisions, which meant pushing away some of the important infrastructure builds that they needed to do the testing that would have been required to test it. And so I think they were caught in a quandary. They decided late about what they were going to build, and they didn't have enough time to build the rest of the infrastructure they needed to do it the way the United States had, because we had already had a few years lead time. And they were pushed by the political leaders to try to get this before the 50th anniversary of the Soviet Union, of the Russian Revolution.
So you talked a little bit about, keeping an eye on China currently.
Yep.
It seems like there's Russian astronauts that have been in the space station.
Yep.
I mean, it feels like there's a little bit more sharing going on.
Mm-hmm.
How would you characterize it? I mean, is it really that adversarial versus at some point everybody might take advantage of everybody else's technology?
I think the level of competition is not the same as it was in the 60s for sure, right? I think there's a lot more cooperation. I mean, the Artemis program relies on Canadian technology and relies on European technology. There's a lot more unified international cooperation for space. But there's still, landing a human on the moon is a signal for national pride, right? And the second country to land a man on the moon is going to have that national pride. So whether they're the first or not, it doesn't matter. That they can show that they have the technology and the capability. It's a demonstration of your technical capability. And so in that sense, it is, there is a sense of competition, right? But I don't think it's anywhere near what it was in the 60s.
I appreciate your presentation. How did you acquire the expertise you displayed this evening?
Well, there's a lot of reading, a lot of reading of quite a few books on the history of the Soviet space program. There's an excellent book. It's really, I characterize it as a doorstop. I think it's like 1,100 pages. It's by a man named Asif Sadiki, and it basically chronicles the history of the Soviet space program. And in the early 2000s, he went to the Soviet Union and went through all the records of the history of the Soviet program and put together a really fantastic compilation of the history of the Soviet space program.
And then, if you didn't catch at the beginning, Moda's also a docent down at the San Diego Air and Space Museum, so he's up close to this stuff a lot. I'm sure that it's a complimentary work. Okay, everyone, I think that's pretty good. Thanks for the questions. Thank you. And Val does have a good image of Jupiter on the way out if you want to get your eye on the eyepiece out there and something to see. We got a nice clear sky after all that rain that came through. Take care, travel safe home. See you next month.
Can we have something that would talk a little bit about the